So there was a lot of companies back in 2014, 2015 that focused on DeepMind, SkyMind, MetaMind, etc. We're part of kind of that wave of companies. So SkyMind builds AI infrastructure for companies who may not be able to build it themselves. And we help companies implement best practices for understanding how to scale AI workloads effectively, whether that be on CPU or GPU, and things of that general nature. So what I'm going to talk about today is focused more around our experience in the market and what customers kind of struggle with when thinking about how do I actually deploy AI. And the reason I'm giving this talk is partially because we only ever think about the math in the latest paper, but we don't actually think about how this stuff is done. And sometimes we think we can take advantage of the cloud, but then we realize that, oh, even the cloud is just infrastructure that we have to assemble into something coherent for our use case. So what I'm going to start with is kind of a brief description of what I'll call the hierarchy of AI. So there are a number of companies out there who kind of think about AI as a buzzword. Some have actually mastered it. Like, they build their own AI tools, their own frameworks, and they know how to use AI effectively. But it turns out, I will say most companies today are actually not very sophisticated yet. Many companies today, barely are able to do basic linear regression, for just basic forecasting, right? And despite all the information we see about GPUs, the latest deep learning paper, most people don't actually use that stuff in production. Very few people, so it's growing, but what you're going to find out there in the market is that if people have machine learning at all, they're using regression. Otherwise, it's probably static rules engines. That's not something people actually acknowledge in the market today. We all want to believe that we're all moving forward and we're all Google. We're really not. And it's going to take a few years to get there. And so, that being said, we can get there. It's just, it takes time, and you have to, you can't tackle it as as one step. It has to be gradual, because you build up the software expertise over time. You acquire data, and then eventually, and even if you have data, it's probably stored in 10 different data warehouses. So maybe you need to centralize your data first. So that's it's just these minor things that we don't think about until it's too late. And so what I'm hoping to do is kind of show what are these different kinds of tiers of companies, and kind of start from the backwards. So first of all, what is AI? These companies tend to have maybe they did an AI POC, but maybe it's not in production, right? I actually see this a lot, especially in Asia. I actually live. For what it's worth, I actually live in Tokyo, Japan. I'm from San Francisco, but I haven't been back to the US since March. So I spend, a lot of my views are, I would say, from Asia, but that being said, we also have a number of American customers as well, and we see varying scales. But this is by far most of the market. They do a basic AI POC, and then they don't move forward at all. Because they don't know, they question the value, or they don't understand what should I, how do I get ROI out of this? They hire a team of data scientists, and then they don't know what those data scientists do. And so there's a lot of pitfalls around that, because people try to dive in too early, rather than asking ourselves, what should we be doing with this, and what is actually useful? Then next is kind of tier 3. So these are companies that have some very basic AI, but maybe have some basic storage infrastructure in place, but not much else. So, these are the people. So, one mistake I see people making in the market is that they think their dashboard that counts things is AI. And when I say AI, in this context, I actually want to say machine intelligence. I hate the word artificial intelligence, but I'm using it. I'll kind of use both. But think of it as decision making only, right? Dynamic decision making with probabilities, right? So since I have a lot in the market. Tier 2. So I would say this is where most companies should strive to get to, at least. You have, so who are these companies? They have, they at least have basic software engineering practices, and kind of built into the company's processes. Better, good quality assurance, centralized data warehouses, Another thing I'll say is proper procurement of data. Like in the market, sometimes it might take you months to even get data for your basic machine learning problem. Sometimes there might be regulations in place, especially with things like GDPR now. So usually companies can navigate this, and usually this is what they should be doing. This is what they should be aiming for, right? So it's just something to think about. You don't need to be Google. You don't need to be Tencent, Alibaba. You don't need to be these people. You don't need to build your own deep learning framework. You don't need to. You can use the widely available tools out there in the market. NVIDIA has helped with a lot of that with their GPUs and CUDA and things of that nature. There's open source frameworks now out there, TensorFlow, PyTorch, that are widely used in the market. So many of these things are widely available, right? So you don't need to build your own tools, right? Just think about that as you're looking at these companies. You probably don't have their scale of problems or their data. Most people don't. Most people aim for this. Like they implement the latest technology, and then they realize, actually the more basic tech could have solved my problem faster. And usually, what you find is if you use technology from these kinds of companies that they open source, sometimes it may not fit your use case, or you need to customize it, and then you end up needing to understand the technology. So it's just something to think about as your company kind of engages with AI. Whatever your stage of maturity may be. So what I'm going to get into now is kind of the components to build AI infrastructure. So so when we think about infrastructure, there's a lot of different environments: on-prem, hybrid, public cloud. And what we find is that there's a lot of infrastructure comes down to the same components: networking, hardware, disk. The cloud is making these things easier, but we still have to understand how these things operate. And if you take one lesson away from today's talk, it should be that, right? So these are the components that data scientists don't think about as much, but really should. For example, if you're doing a distributed job and your job runs out of memory, what happened? Your GPU, if your GPU is maxed out, how do I better provision my machines to handle higher end workloads? Do I need the latest NVIDIA GPU, or maybe if you're doing inference, maybe you need a P4 instead. Maybe you need smaller GPUs with faster uplink, right? There's little things to think about in the hardware, all the way up to the software. Like for example, when you're, one thing you do in machine learning is something called ETL, extract, transform, load. So that's just when you're loading data from disk and putting it into a usable form for machine learning algorithm to consume. Right? So sometimes you may need to think about where is your data stored. You may need to think about networking, etc. So you need to think about this whether you're doing on-prem or whether you're doing things like cloud or hybrid cloud. And even when we're thinking about cloud or cloud versus multi-cloud or what have you, what you then find is that these things have these trade-offs, and usually people are using multiple environments for different use cases. And that's usually depending on the regulations that the company is subject to. Sometimes it just depends on where data already exists. Some people dynamically migrate some workloads to the cloud. They spin up they run their jobs and then they spin it down, right? So the cloud allows us to do that today. Some things run on-prem, right? So but again, all the same concerns still apply no matter where you're running your workloads. And so here's the typical development lifecycle for machine learning. We acquire, we kind of, we define so let me think about this. So when you define a problem, right? So what do I mean by that? When you define a problem, you have a wide variety of things to consider. Should I use machine learning? That's the first question you actually should ask. Do I need this at all? Right? And then from there, you acquire the data for your problem. That might take 3 months. If your company's bureaucracy is anything like this, it'll probably take 3 months. You never know. It really depends on what company you're working at. Again, just think about those tiers that I mentioned earlier. Then you transform the data, you train your model, you validate it, you rinse and repeat, right? So we do this to put models into production and to actually get them used by the company for real value. Some companies just stop at training the model. They run experiments, they spend 2 weeks doing it, and it didn't work. And there's nothing wrong with that. That being said, sometimes companies don't measure what are we spending, what are our data scientists spending our time on? They don't. Sometimes you don't think about that side of workflow. So instead, from that being said, think about how you can get more models into production, rather than trying to think about what experiment should I run next. If you do endless R&D and don't benefit from it, you're just paying people salaries.